You are welcome to another series of practical in general biochemistry. Today, we shall start the practical fully. Last week, we dwelled much into the concept of numeracy, whereby we were exposed to how you can convert from one unit to another. Today, we shall be looking at the determination of pH of a solution using indicator method. In the theory class, you have been exposed to the concept of pH. By now, I want to believe every 200 level biochemistry student, or every student in 200 level offering biochemistry can define pH conveniently as the degree of acidity or alkalinity of any particular solution. Before we go into the laboratory work today, let me introduce the crew, those that will be working, handling the practical procedure together today. I have Mr. Wale James with me, and Mr. Peter also with Ayodele. Any moment from now, also Mr. Charles Lee will also join us in the course of the work. Last week, I implored us to approach the biochemistry department to get a copy of the BCH practical manual, because most of the things we shall be discussing are going to be dished out from the manual. So the practical procedure we shall be dealing with today is found on page 7 of the manual. Page 7, under the title pH and buffer. We are not going into the concept of buffer that has been taught in the theory class. What we are going to do today is determination of pH of solution using indicator method. And the name of the indicator we are going to use for this practical procedure is bromothymolblue indicator. Bromothymolblue indicator. So, before I explain the procedure, I will equally like to inform you that we have so many methods of determining pH of solution. You have the one you can use your equipment known as a pH meter. You can also use a fast method. If you are on the field, you can use a strip called a universal indicator paper. Why you can also use your laboratory method, which is the one we are using now. So for the purpose of the majority of us that are not exposed to the equipment used in taking pH of any solution is known as pH meter. This is a typical example of pH meter. Here, this one, the pH meter comprises of the output unit, the power section, and then the probe known as electrode. This is a typical example of a pH meter. With pH meter, you can easily detect or measure the pH of any particular solution. We are not going to deal with that as much today. I only want to show you that and let you know that the equipment, you can use equipment in taking the measurement of your pH. The name of that equipment is pH meter. We have it in different sizes for different manufacturers. This is the particular one we make use of in our laboratory here. There is another method of determining the pH of a solution through the use of a universal indicator paper. It comes in different sizes too, in form of a paper strip. All you need to do is just to take out the strip, dip it inside the solution you want to measure. You already have coded colors that have been graded according to the level of the pH. And immediately after you dip inside the solution you want, the test solution, Then whatever color that will be developed, you match it with the color that you have on this cartridge. So whichever one it tallies with, will give you the corresponding pH value of that particular solution. It's a very quick and a fast method that we use when you're on the field to determine the rough estimate of the pH of that particular test solution. So we go back to our laboratory work today. The use of bromothymolblue indicator. You have to prepare a series of 11 standard solutions in 11 different test tubes. I want you to listen carefully to the procedure. By now, I expect you to open your manual to page 8. There is a table there, table 3.1, under phosphate buffer standard solution. Because the salt we are using is a potassium dihydrogen phosphate. So the buffer standard are known as a phosphate buffer standard. We are going to prepare 11 of it in different pH ranges. Like I said, you select 11 clean test tube. 11 clean test tube. Nobody is going to clean the test tube for you, but the test tube will be provided for you. The owners now like on you that you clean the test tube properly before you continue with your procedure. So, having done that, into test tube 1 to 11, by the table here, you are required to pipette 5 ml of potassium dihydrogen, 5 ml of 0.1 molar, which has already been prepared for you. You prepare 5 ml of 0.1 molar potassium dihydrogen phosphate into each of the 11 test tubes. Having done that, you start all over again from test tube 1 and begin to add 0.1 molar sodium hydroxide solution into each of the 11 test tubes. But the volume or the quantity of sodium hydroxide varies from one test tube to another now. To test tube 1, you have 0.56 ml. 0.56 ml of sodium hydroxide. While test tube 2, you have 0.86. Test tube 3, 1.26 ml. 1.77 ml. 2.36 ml. 2.95 ml. 3.49 ml, 3.93 ml, 4.27 ml. To test tube 10, you add 4.52 ml, while to test tube 11, you add 4.69 ml. In that order, chronologically. After you might have added the two together, that is potassium dihydrogen phosphate and sodium hydroxide, you mix the content properly by taking the test tube out of the rack and you shake properly. After doing that, you are also required to add the various quantity of water into each of the tube. From test tube 1 to test tube 11 also, the quantity of distilled water that you will add to each of the test tube also vary. To test tube 1, you add 4.4 ml, 4.44 ml. To test tube 2, you add 4.14 ml. As you can see them preparing. You can see Mr. Peter preparing it using the pipettes accordingly. To test tube 3, you add 3.74 ml of water. While to test tube 4, you add 3.23 ml of water. In that order, until to test tube 5, 2.64, followed by 2.05, 1.51, 1.07 ml, 0.73 ml. To test tube 10, you add 0.48 ml of water. And to test tube 11, you add 0.3 ml of distilled water and mix properly. So as you can see, The preparation is ongoing. Don't back. So that's how you will continue the procedure stepwisely until you are able to prepare all the 11 test tube. The 11 test tube, after adequate preparation, will stand or serve as our standard preparation. After adding the three solutions together, that is the potassium dihydrogen phosphate, sodium hydroxide, you have to shake the content of each test tube properly across both. That is from test tube 1 to test tube 11. Also, the unknown solution that we want to use this method, this procedure to determine the pH here is in our test tube 12 and 13. And inside the test tube 12, test tube 12 stands for urine. We use a urine sample to prepare that. While test tube 13 is our saliva, as you can see inside the sample bottle. 1 ml of the urine was taken into test tube 12, while 1 ml of saliva was taken into test tube 13. And then 9 ml of water, the still water, was added to it to make an equal volume with the rest of the test tube. From test tube 1 to test tube 11 here, if you check the total volume of solution we have here, you will notice that it's 10 ml each. So if you check your manual, you will see them. The first one is 5 ml of potassium dihydrogen phosphate plus 0.56 ml of sodium hydroxide, and with 4.44 ml of distilled water added to it. If you add the three together, it will give you 10. Because of time, let me go to the content of tube 11. Tube 11 contains 5 ml of potassium dihydrogen phosphate, followed by the addition of 4.69 ml of 0.1 molar sodium hydroxide, and with 0.3 ml of distilled water added to it. Everything added together, 5 plus 4.69 plus 0.31 will give you 10 ml. So in every of the test tube, from test tube 1 to 13, you have 10 ml solution in each of the test tube. Now to get our color, to develop the color, what we will do now is to add the same quantity of bromothymolblue indicator across board. That will be done now by Mr. James. Three drops of bromothymolblue will be added directly into the solution. And while adding, you make sure that the 3 drops go straight into the solution, not at the side of the test tube. Now that bromothymolblue indicator has been added into the content of each test tube, there will now be need to mix properly. As you can see, you need to mix properly. So to achieve that, you do that by taking each test tube, cover it with cellophane, and you infert about 2 or 3 times, or even 5 times to mix properly. You infert, then you return to the position. One blue indicator into the standard and the test sample, As you can see, these are the shades of color that come out from each of the solution based on their degree of acidity and alkalinity. You can see from test tube 1 here to test tube 11, we have different shades of color, ranging from a light yellow, yellowish blue, to 11 here that you have a deep blue color. Now to determine, having prepared this standard from tube 1 according to our table and phosphate buffer standard on page 8 in our manual, this tube 1 is standing for pH of 6.7, tube 2 is standing for pH of 6.2, tube 3 6.4, tube 4 6.6, tube 5 6.8, tube 6, as you can see the color, 7.0, while tube, what's the next tube now? Tube 8 7.2, tube 9 7.6, tube 10 7.8, and tube 11 8.0. That is from tube 1 to tube 11 we have a different pH range from 6.0 to 8.0. Now to our test. The first test here is our urine sample that we don't know the pH. What we will now do is that we will now begin to, the color that developed from this urine sample, we now begin to match it. We call it color matching, one by one, with each of the test tube. Whichever one the color in this test tube for the urine sample tallies with, that means the urine sample prepared there is having the same pH with that particular standard. So let's begin to, for urine sample, let's begin to do the matching. And let me also inform that it's possible while doing the color matching, that is trying to look at whichever one the color tallies with. It's possible the color may not tally with any particular standard directly, but it may be falling in between two standards. So in that case, what we will do is that those two standards, you take the pH value and divide by 2. So that will give you the average pH of that test sample. So let's match this one. Looking at this, the color of this urine sample is very close to this one, but a little bit thicker than that of standard. Then we move to the next one. Can you see? It's almost the same or nearly the same color with test tube 2. So with this, it's even the same color as you can see here. With this, you estimate the pH of this urine sample to be the same thing as the pH of this standard test tube 2. If you go back to your manual, test tube 2 here stands for pH of 6.2. So automatically we have been able to deduce or estimate that the pH of the urine sample we use for this practical procedure is 6.2 or around 6.2. That of saliva, as you can see, that of saliva, we also margin. You can even see this one that it doesn't fall in the range of the yellowish something. It's tending towards bluish color. So we begin to pick it from here. It's more bluish than this. As you can see, the color of the test sample that contains saliva tallies with that of tube 7. Can you notice that? So the color is almost the same. So you now go back to your manual. Tube 7 is having what pH? So to 7, according to our standard table, is 7.2. So that means the saliva we use for this procedure is having pH of 7.2. Ladies and gentlemen, this is how to use an indicator in the laboratory to determine the pH of unknown solution. Determine the pH of unknown solution. Now the question now is that our unit sample is having a pH of 6.2. What type of pH is that? Is it acidic? Is it neutral? Is it alkaline? Is it slightly acidic, slightly alkaline, and so on? So from our pH scale, that's what we call pH scale. The pH scale ranges between 0 to 14. While pH of 7 is taken as a neutral pH. Below 7 is acidic, and greater than 7 increasing acidity. Increasing alkalinity. As a pH tends away from 7, the acidity of that particular pH increases. And as the pH approaches 7, the acidity decreases. So, from the scale you have on the board here, if pH value is moving closer to pH of 7, that shows that the acidity of that particular solution is decreasing. If it's moving away from 7, that is reducing from 7 towards 0, that means the acidity of that particular solution is increasing. And if you move to the other side of the scale, which is beyond 8, as the pH increases, tending towards 14, the alkalinity of that particular solution is increasing. And if the pH is reducing or coming towards 7, the alkalinity is reducing. And the white 7, pH of 7 is taken as a neutral. So from this explanation now, we can always come back to our practical today. The unit sample is having pH of 6.2. So what type of pH is that? 6.2. Is 6.2 closer to 7 or far away from 7? You can say it's closer. So we can say that the unit sample is slightly acidic. Why that of saliva is 7.2? 7.2. Even though it's above 7, but a little bit. So how do we call that one? Slightly alkaline. the pH of 7.2 is slightly alkaline solution. So, ladies and gentlemen, that's the end of the practical today. But before we round up, we would like to show you the apparatus and equipment used in today's practical. Today, we make use of 10 ml pipette. This is a pipette. This is also a pipette, but in different capacity. This is 1 ml pipette, while the one on my left hand is 10 ml pipette. We also make use of test tube, as you can see, for those of you that can't differentiate between the glassware test tube. And we also make use of measuring cylinder. This is 50 ml measuring cylinder. We also make use of partial pipette. Partial pipette to take the drops of the indicator, while we also make use of another glassware called beaker. And apart from all this, we make use of our weighing balance. This is a weighing balance. We make use of it to take the quantity of the salts that we use, to take the weight in gram of the salt we use. And this particular weighing scale can have the capacity of measuring into 2 decimal places. I've shown you this earlier on. This is a pH meter. That is instead of this laborious work we do now, measuring one by one, using different glasswares and apparatus to take measurement, the machine can determine the pH of the solution immediately without going into all this stress. But as a student that is learning as a scientist, it is required of you to be exposed to laboratory method. And I'll show you the universal indicator paper. Also, this one too can be used to estimate the pH of solution directly. And the method we use here also today, color matching method, is also what is involved in using the universal indicator paper. After taking out the strip and you dip it inside the test solution, particular color will develop here, then you match the color with the one on the cartridge. Whichever one the color tallies with is taking the pH of that color code. So it's the same thing as color matching. Gentlemen, until next time we meet again in this biochemistry lab. This is General Biochemistry Laboratory. We have the test student on the practical. This is General Biochemistry Laboratory, College of Biosciences. In the course of the practicals, you will still be meeting with so many other lecturers in the department, because each lecturer will need to come in the area of his own specialty to take you on the practical. Thank you. We meet again next week.